Okay, so as I said in the next video, we were going to look at the tic-tac-toe smart contract. I've gone through this one, like, I don't know, 2 or 3 times now. Each time each time they update the Dawn version, and I don't really like it. It's not really that great of an example, and I don't know, the way they lay out the tic-tac-toe board is kind of confusing. So I decided instead to use the Kevin Heifner OCI address book example. I'm showing you this because I really highly recommend this video. He does a great job here. I wanted to give him a good shout out. I think it does a better job of like explaining how to interact with the database and motivate the example a little bit better than the tic-tac-toe example. So that's actually the example that I want to use. So let's spin up Node-EOS again from fresh. I'm going to delete all blocks so you know that I'm doing everything from scratch the first time. So in the last video we deployed this Hello World smart contract. Oh, by the way, as I mentioned in the previous video, I was like, oh, I'm not sure what these are and these are. I forgot Kevin actually goes over that in the YouTube video, so definitely check that out. There's really not much going on here between these two bits of syntax, so I don't know. I'm not going to go over it. It's kind of trivial stuff. So we know how to deploy a smart contract. We kind of know like what actions are and different things like that. So essentially what he's done in this address book tutorial is he showed you how to interact with the database, or what we would consider a database in EOSIO parlance. And what he's done is he has created what he calls an address book, as you can see from the file name addressbook.cpp. He creates essentially this is how you create a database or access RAM in the smart contract. What you'll do is you'll create a struct. In this case he calls it address, and this struct has different fields. It has an account name field, it has a first name, last name, street, city, state, a zip code, and a liked number. And these are just fields in a struct. If you remember back to the previous videos where we talked about the boost multi-index, I mean, it's exactly the same thing going on here. Then they'll define a primary key. So this is one of the differences between the boost multi-index and the EOSIO multi-index. It's very small syntactic differences, but really, as you'll see, overall it's essentially the same data structure. So here we have the primary key method, and this kind of this tells the multi-index what key to use as the primary key, what field in the struct that you want to use as the primary key with which you're going to do queries and updates on. Here he defines a secondary index. As we saw in the boost multi-index, you can do that, primary and secondary indices. In this case we have the by zip index, and in this case you're able to query on zips essentially. So then another kind of little bit of flavor thrown on top that isn't in the boost multi-index is its EOSIO Lib serialized macro, and all this does, as far as I understand, is give you a way to serialize and deserialize data. In this case, this struct, we would want to be able to serialize and deserialize that. It's mostly for efficiency gains and the fact that things need to be sent over the wire in blockchain smart contract development. So we have this struct, and we've essentially, I mean, the way I look at it is that you start out defining what data you want, and then you add these 3 little fields here, and that allows you to use this struct in a multi-index. And in this case down here, this is how we do the definition. And again, you'll see it's very, very, very similar to the way we did the boost multi-index, with the exception of these n macros, which we've already discussed in a previous video. So here we're giving an address data. Essentially, these address structs is telling us what we want to store in this multi-index, and then we're giving it a secondary index. In this case, we're able to index the data based on the zip code. And then just calling out again here, down here, you'll see again we have this EOSIO underscore ABI macro, same as we did in the Hello World example, and we're passing it address book, which is the name of the smart contract and then all of the actions that we want to support and we want the ABI to be generated for. So that is essentially the multi-index that we'll be playing with in this example. So if we go up into the different actions that are supported by this address book smart contract, the first one, and the one he goes over in his video, is the add action. And what this allows us to do is add things to our database row. For such a trivial action, there's actually a lot to unpack here. So similar to the hello world one, right? We can pass in any number of parameters here. In this case, we're passing in the account name, the first name, last name, street, city, state, and zip code for an entry in the address book. And you can see here we've discussed already the require auth as we had here in the hello world example. Again, we want to require the authorization of the account, and we'll see why down at the bottom of this action later. One thing he calls out in his comments is, and this is something to be aware of, anytime an authorization fails, all of the transactions up to that point are rolled back. So let's say we put in a require auth down here at the bottom. Well, all of these actions that we did where we're placing addresses inside the address book will get rolled back as soon as the required auth fails. In this case, there's no actions to be rolled back, but it's definitely something to be aware of because occasionally we get asked in the Telegram for specific use cases. So right here what we're doing is creating the table if it doesn't exist. Otherwise we're getting the table, as you can see here. So this is almost like the way I would think of it is like a constructor for our database, which we'll use to store addresses in, essentially. So the first thing he does, like let's say, okay, so it's a get or set here, right? We're either creating it or we're getting this address RAM chunk, I guess, database, whatever you want to call it, multi-index. The first thing he does is he'll try and find the account. So because we have the primary index, or sorry, the primary key function down here, we're able to call find up here, addresses.find, and pass in the account name that we were given in this action. So the first parameter is the account name. We'll try and find a record in the database with that account name, and if we do not find it, we will move on to the next step. Otherwise, this will also get rolled. Anything that fails in a search statement in EOSIO will also get rolled back. So everything up to this point will be rolled back as well if the account already exists. So after that, we are able to actually store the field in the database. One thing he points out here and is definitely necessary to be aware of, because again, this comes up very often, is the account. The very first argument in the in place method of the addresses database is who is going to pay for the RAM. In this case, we want the account that's going to be storing their data in the address book to pay for the RAM for their storage of their field. And that's why we needed the require auth up here, why we needed the account name itself to actually sign the transaction, because we're going to try and store things in the database using their EOS in order to pay for the RAM. So right now is kind of a good time to talk about RAM storage. So that comes up fairly frequently. Everyone's asking, how do I do an airdrop? How do I do an airdrop? Well, in order to kind of store who owns which tokens, you actually need to interact with. So you could use very much the same smart contract, or at least these same operations that Kevin is showing you how to do with this address book. You can use these to kind of do an airdrop yourself, really, because all you be storing is an account name where the tokens exist, and then a balance at that account name. Like, so if somebody owns 450 of your airdrop token, you need to be able to store that somewhere. Well, you actually have to pay for that RAM, right? Or somebody technically has to pay for that RAM when you do an airdrop, because you have to store those balances somewhere on the blockchain. Currently, I'm not sure when I release this video or release this course, but there's a whole bunch of arguing going on as to what we're going to do about. So there are all these RAM speculators. People are buying RAM and driving up the price of RAM, making it more and more expensive to actually store things on the EOSIO blockchain. And the developers are really pissed about this, and they're going, how are we going to fix this? Why are the block producers not adding more RAM to the blockchain, and how do we fix the speculation that's going on here, because EOS uses the Bancor algorithm in order to price RAM, and currently the price of RAM is off the charts. So that's I guess one reason to be aware of who's actually paying for the RAM storage here in this case of this database. Another thing to be aware of is and this gets asked quite frequently as well, is how do we remove the RAM that we've stored on our smart contract up to this point? Well, you need to give a way for your smart contract to actually delete its RAM before you get a close up. People want to essentially be able to delete their smart contract. Well, how do I do that? If you just delete your smart contract without cleaning all the RAM, well, that RAM's stuck there forever. No one's ever going to be able to clear it out. So you actually need to be cognizant and be aware of like what you're storing on the RAM, and kind of how you're going to clear that RAM data out again. Anyway, so big digression there, but I just wanted to call that out and make you aware of that field. It's very, very, very important field, especially right now given the price of RAM. So we pass that parameter, and then after that you pass in a Lambda. We've already discussed Lambdas in a previous Intro to C++ video, and this essentially is the address that you'll be storing in the addresses database here. And so you're setting this field, you're getting access to this field of, the database knows it has a whole bunch of these records in it. You're getting access to that through this Lambda, this address, and here you're setting all of the fields that were passed into the smart contract by the user. So one final thing to call out with this add method is, this question gets asked quite a bit as well, is how do I call other smart contracts from another smart contract? And essentially this is how you do it. You use the EOSIO Action, you give it a permission level. So let's say up here so essentially what I'm going to do is I'm going to call the hello smart contract that we deployed previously, and I'm going to call this high action. So the parameters passed to this EOSIO Action are the permission level, the contract you want to call, the action you want to call it with, and then the parameters you want to pass, and then you call .send after that. So essentially what I'll be doing is I'll be calling the hello contract, the high action, and the hello contract, and then I'll be passing the account name that were passed here to that action. But the first parameter to the action, the EOSIO Action method, function, and whatever you want to call it, is this vector of permission levels. In this case, I'm passing it an empty vector because we don't need to require any authorization to say hello to the user. But if I were going to do that, this is how I do it, and this is actually how Kevin does it in his video. Okay, so that is the add action. He also has an example of updating a record. It's very much the same as adding a record. He does the same asserts to make sure the address is actually in the database, and then instead of calling update as we had up here, or sorry, in place as we had up here to add the row in the database, here instead we'll be modifying it, and we'll use the iterator to tell the function essentially which record we want to modify based on the one that we found here, using the same find method that we had before. Again, the account, this is a crucial thing to be aware of, is who's paying for the RAM. And then again, we have this Lambda function, and we are editing the fields in the address that we're using to point to using this iterator up here. So that's how you would update a record. Again, I really like this example because it's essentially a CRUD, right? It's a CRUD application. It shows you how to do a CRUD application on the EOSIO blockchain, which I think is very, very important to know how to do: create, read, update, destroy. So if we move on to the next step, which is remove, this one's a much easier example. Again, we get the addresses database if it doesn't exist, or we create it. Here we're finding the account that we want to delete. We're making sure that it exists in the database, and then finally we're calling erase on that. Notice we don't need any lambdas, we don't need anything here, because all we're doing is erasing a record from the database. So another action or another functionality he supports is the ability to like addresses. So if you'll see here, he has added this field liked, and this kind of shows you how to modify one particular field rather than modifying the entirety of the the record. In this case, it's saying, okay, I want to like this account. I do all the other same. Like you can see here, these steps are repeated frequently over and over and over again. Again, we're modifying based on the iterator, assuming we found the iterator in there. In this case, the smart contract is paying rather than the payer. So if you pass in a 0, the smart contract will take care of the payment of the RAM. And where it's just a modify, it's not going to cost, shouldn't cost any more extra RAM. Then again, the address, here we're doing a print statement to debug whether or not this succeeded. One thing to point out here I thought was kind of interesting is this shows you how to print out a string. Previously all we've printed out were account names, but here's how to print an actual C++ string to the EOSIO console. You just pass the string.cstring and print it out that way. And then we're incrementing the amounts that have liked that record in the database. Finally, he has one final example. He even points out himself in the video. It's kind of a trivial example, but as I've said previously in this course, I really like trivial examples because it abstracts all the difficulty crap out of the way, and you can get right to the meat of like what's really going on here. So for this final action, he does a like by zip. So previously we were using the account name, which was our primary index in the database. In this example, he'll use the secondary index, which is exactly like our Boost Multiindex earlier part of the course where we were going through this in detail. We're showing how to get this secondary index. In this case, we wanted to index by the zip code. So we're given past the zip, we get the zip index, and that allows us to find the records with that zip code, essentially, rather than getting an account name, which is a primary index. So we get the lower bound. This will get everything up to the first record of zip codes that we wanted to find, and then you can see he's iterating through all the rest of them. So if we had, for example, let's go back down here. If we had, for example, something like this, we had zip code, zip 0, 1, 1, 1, 2, 2, 2, 3. Like, let's say those were our zip codes that were currently in the database, right? And each of these zip codes has their own name, first name, last name, all that other crap that we're storing in the database. But in this case, all we care about are the zip codes. Well, let's say we wanted we called the lower bound zip of 1, right? It would skip 0 and then go up to the, it would match, the iterator would be pointing at this first 1 zip code. And then down here he's iterating through and modifying each one that matches that same zip code. So he would modify this record, increment the liked by that, increment the liked by that, increment the liked by that, and then he would get to this index in the database and check it and go, okay, this isn't the right here. You can see he's checking if the zip code's correct. Oh, this isn't the same zip code. He would skip it, move on to the next one, skip it as well. So only the zip codes with 1 would get incremented for their like. So that is essentially the address book, very deep dived. We covered a lot of really good information here. In the next video, we'll actually deploy this smart contract, we'll interact with it, and do a little bit more kind of explaining as to what's going on. So I'll see you in the next video.